Hello and welcome to this session focusing on the maths content within T-level programmes. This is a recorded version of the live CPD event that took place on the 31st of March. So my name's Elena Bennett and I work in the provider development team at NCFE. Previous to this, my experience was as a maths teacher in secondary schools and colleges for around 25 years. Mathematics plays a crucial role in T-level qualifications, but we do understand that many students face challenges when applying mathematical concepts in both their core and occupational specialisms. So in this session, we'll explore some of the common maths challenges that students encounter and discuss a range of strategies and practical approaches to help them overcome these barriers. We'll start by having a look at where mathematics skills are embedded within T-level qualifications. So these essential skills are not taught separately, but are integrated into the qualification content. This means that all students must learn them as part of the course and they will be assessed on their application. For example, in core component examinations, students will need to demonstrate their understanding and use of mathematics, and this could involve answering questions that require rounding to a specified number of significant figures or decimal places. And in some cases, marks will depend on providing the correct level of accuracy. It's also important to remember that technical qualifications must include sufficient English, maths and digital content in order that students completing a T-level will have threshold competence in their chosen occupational area. For more details, the qualification specifications provide a clear framework of competencies that may be included in assessments and where these align to core skills for your qualification. The expectation for students to use mathematical skills is also highlighted in the core component grade descriptors here. In terms of difficulty level, most of the T-level maths content does not go beyond GCSE level, so your students should have encountered it already. Only a few topics such as statistical analysis like t-testing, Spearman's rank, chi-squared or using standard deviation and variance may not have been familiar at GCSE. Despite this though, it doesn't necessarily mean that your students will be able to do all of the maths content. If your students have achieved, for example, grade 7s, 8s and 9s at GCSE, they should find the content pretty accessible. However, those with a grade 4, 5 or 6 are still working towards that grade 4 may well struggle with some of the maths content. Now we'll explore a few of the key areas of challenge arising from comments in Chief Examiner reports. What we'll focus on in this session are some of the main overarching skills that are applicable across a range of maths topics and across the different T-level qualifications. So the first area we're going to look at is around students showing their working out. There's a question here which is taken from a health paper from Autumn 2022 series. It's a 2-mark question, and what I would like you to do, if you want to just pause the recording to give yourself a few minutes, is have a look at this question, and the mark scheme is at the bottom left of the page, and there are 2 sample student responses there. I would like you to have a think about what you would award each of those 2 students. So pause the recording here while you do this activity. Okay, so looking at the responses, the first student is actually awarded 2 out of 2 marks. Despite the fact that all they've written is the answer, the question doesn't specify that they need to show they're working out for this question to achieve full marks, so they would gain all of the marks for the question. However, the second student would only gain 1 mark because although their method is correct, perhaps they've made a calculation error and their answer is not correct, so they would gain 1 of the 2 marks. So the reason that we had a look at the question on the previous slide was just to make sure that when you're working with your students, they understand the importance of working out and how it may well affect their marks. So these comments here from Chief Examiner reports suggested that Overall, students attempted this question on the right well, with many of different versions of working seen. And that's fine. If students use a different method to one that you're familiar with, encourage that. And sometimes them showing their peers can be really useful as well. However, there were some avoidable calculations seen, so students should allow time to carefully check and proofread their answers. And where the question requires working to be shown, they must do so. You can see this question, it states quite clearly, show your working. If the students just write the answer, despite the fact it may be correct, they will not gain all of the marks for the question. The second question is the one we just did on the previous slide. And this, again, most students could do, although there were errors in calculations seen and also some blank responses. So this question, it does not require the students to show their working, so it is possible to gain full marks with just the answer, although good exam practice would suggest that methods should be shown unless the question states otherwise. It's very important for students to show their working because it's easy to trip up and make a mistake in a calculation and lose marks through that. So in relation to showing working out, we're now going to move on to thinking about how students structure and present their work in a logical manner. So many students do lose marks on maths questions because they don't approach them logically. So this is an example here from an education early years paper where the students failed to show a breakdown of their calculations and therefore did not gain full marks for it. Many responses were also containing complex calculations leading to incorrect conclusions. It's essential for students to present their answers clearly and logically because sometimes this lack of clarity actually prevented the examiners from being able to award marks accurately. So really push with your students the importance of their work being logically structured. Even if they have made a mess on their page and there's a lot of working out, even if they could number each section of their work logically so that it's easier for the examiner to work through. So following on from students showing their work in a clear and logical way, we're going to take a moment to look at this question from an Education and Early Years core paper. So I'd like you to just take a moment to think about how you could help your students break it down into smaller and more logical steps. And what would each step be? So if you want to pause the video here for a few minutes where you think about that. So not necessarily the answers to the question, but how you could help students to break it down bit by bit. There isn't necessarily one correct answer here. Okay, so my suggestions here would be that the first step would be to calculate the number of children attending the nursery based on the occupancy rate given of 72.5%. Then, once they've calculated how many children, they could work out the cost of the meals for one child for one day. So you're adding up breakfast, lunch and snack for one child. Then you can work out the cost for all of the children for one day. So you'd multiply it by your answer for the total occupancy of children. And then finally, the nursery is open 7 days a week. So you would need to work out how much the nursery spent on food for the full week. So multiplying your answer by 7. So looking at the actual calculations here, I've just made a few notes that you might find useful. Now, when students work out percentages, there are many different variations and methods available to them. So I've put a couple of methods here, but be aware that your students may be more comfortable with other methods, so encourage them to share methods with their peers, because sometimes you find that actually they can kind of latch onto a method done by one of their peers better than they can by something that you've taught them. Then you'll notice in this question that the units are different. So breakfast is given in pence and the other meals are given in pounds. Now this is quite common on maths questions. So practice in lessons with your students using different units. And that might be money, but it could be things like grams and kilograms. It could be millilitres and litres, centimetres and metres. Just get them used to dealing with different units within the same question or context. Then once they work out the total cost per day, they get an answer of 117.74. Now here I've made sure to put the pound sign in front of that and write down that it's what I've calculated there is the total cost per day. You don't necessarily have to do that at this point, but if your students do come back to this question later on in the exam to check over their answers, it'll mean a lot more to them rather than just put in the number 117.74. They won't remember if that, what does that mean? Was that a price? Was it a number of people? Like they're going to get a little bit confused. So this will really help them to just write down at each step what it is they're calculating and make sure they add the units in. And then finally, their final answer should be really clear, and it should also have the correct units. So make sure if you're dealing with money, it only has 2 decimal places. Otherwise, marks could be missed for that. Marks also could be missed for not including the pound sign. The next area we're going to have a look at is handling data, as this is a common area of concern mentioned regularly in Chief Examiner reports across various T levels, and particularly in relation to ESP assessments. So I have a few direct quotes here from some of the Chief Examiner reports, and I'll give you a moment to just read those and digest them. So starting at the top left there, we can see that in science, students struggle to present more than one set of data on a graph. So, for example, using dual data or multiple data graphs was preventing their achievement. In education early years, most students were able to process and interpret data, although some did struggle in that area. And across into the digital T levels, issues were identified with data cleansing and analysis. Statistical information in healthcare science T levels was available, but very few students actually used this. And again, back to science, students appeared confused over how to correctly interpret statistical tests and how to analyse and explain their data. Then again in health, very few students displayed any numeracy skills via the use of graphs, where that would have perhaps enhanced their work. And finally in science, similarly, students were unable to use Microsoft Excel for statistical analysis, so therefore again limiting their opportunities to gain marks. Another area of data handling where students seem to struggle was in terms of interpreting data types and data collection methods. So for example here, in the science paper of autumn 2023, students gave incorrect answers as they were confusing data types with data collection methods. So students do need to know the difference between them and how they apply in different contexts. Students also fail to understand that using a small sample size may not be sufficiently reliable to generalise to a wider population, and also to recognise that an anomaly in the data could occur with a one-off experiment, and therefore repeated methods would give more valid results. So during the live session, we did this activity around data types and data collection methods, but it's an example of something you could use in helping your students become more familiar with different terminology and differentiating between data types and data collection methods. So you can see here students would have to sort the list of the green words into, are they either a data type or a data collection method, and then find the definition that would match each one. And this is just a screenshot from the completed Padlet with the answers. So this is really just for your information if you did want to do an activity similar to this with your own students. Now we're going to delve a little bit more deeply into the issues around interpreting data from graphs. So the example I've used here was from a science paper in 2023. The question was around a set of employees from a company who completed a test before and after some training. Now the training would cost the company money, so the students have to decide, is it value for money? Is it worthwhile for the company to spend money on the training for the colleagues to improve their scores? So in this question, many students obtained 1 mark by identifying that in each case the training did improve the scores of the employees. However, very few students developed their answers further to include additional detail or analyse the data, therefore limiting their achievement in the question. And you can see it is a 4-mark question, so they would be expecting a deeper level of analysis. So this is the suggested mark scheme from the question on the previous slide. So as we've already said, students would achieve 1 mark for suggesting that the owner should pay for the training because all of the employees managed to improve their scores. However, they need to be a little bit more analytical, and the 2nd mark could be something like, however, most employees only improved their scores by around 10 to 20%, so perhaps that's not enough to justify the expense. And then the 3rd mark could be that actually most employees already scored over 75% before the training, so perhaps it might not be worth paying for. Perhaps they could do something in-house instead, which would be free or cost a lot less money. And then finally, it would depend on how useful the training was. Is the system something that's used frequently, or is it just a one-off? So therefore, would it be good value for money? So you can see the students really need to think around the context of the question, and and potentially both sides of an argument rather than just stating what they're seeing on the graph. There were some other areas of maths specifically referred to in Chief Examiner reports. I'm going to highlight a few of them here and give some examples so you can see what sort of things it would be useful for you to incorporate within your vocational T-level delivery. So firstly, stating the correct unit. Now, the example I've given here is understanding that 3.1 on a calculator display would be £3.10 if we're talking about money. So just make sure that students do give the units in their answers. We've already discussed converting between different units and the fact that a question might contain 2 different units, for example, pence and pounds here. So make sure students are used to dealing with these type of questions, and it could be things like grams to kilograms, it could be centimeters to meters to kilometers, could be milliliters to liters, but students often struggle with these conversions, so keep it fresh and keep them practicing them. Now, students are often expected to round their answers to a specified number of decimal places or significant figures. From experience, students do struggle with significant figures more, so again, it's something worth practicing so that students don't forget and they are familiar with it when it comes to the exam. In terms of rearranging equations, these examples are most commonly found in the science-based T-levels, and it was identified that students are generally okay with substituting numbers into an equation, but when it comes to having to rearrange the equation, that's where they struggle. So it's worth thinking of some strategies to help your students with that. Then avoidable calculation errors. So this could be something like typing the wrong numbers into a calculator, or it could be that students are making mistakes with their mental arithmetic. And the example I've given here is, for example, 0.2 times 0.3 does not equal 0.6. It should be 0.06, but errors with place value are relatively common. So get your students to think about checking their answers on a calculator. And then finally, percentages. Now, these questions do crop up fairly regularly on T-level core exams and in ESP and OS assignments. Now, the areas particularly to look out for are reverse percentages. So the example I've given here is, an item has been reduced and you have to find what the original price was. And also increase and decrease questions. So, what was the percentage increase of an item? So they're all areas worth spending a little bit of time on. Perhaps incorporate them into starter activities or into problem-solving contexts so that your students just, become familiar with seeing them in exam situations. So looking at some suggested strategies that could help you in your teaching in terms of some of the content that we've discussed today. So we'll start with checking calculation, so getting students to be able to identify their own errors in their work and make those corrections. So using spot the error activities is useful, like the example on the right there, where the students would have to look at Bob's answer, see if he's made any mistakes, and if he has, what's wrong with it. And these kind of activities can help where students are lacking confidence or have anxiety with maths and are a little bit reluctant to do some peer marking. Setting up fake kind of answers can really help with that. And it also encourages students to use estimation to check their answers. This can be useful just seeing if their answer seems realistic within the context. And if students do struggle with this, you could create checklists for them to identify, have you checked for this? Have you checked this? Have you checked this? Just so that they're more able to have a structured, scaffolded approach to checking their work. Use real world context, so incorporate math skills into vocationally specific activities, and this can take away some of the pressure and some of the anxiety of it feeling like a maths lesson. Promote the importance of math skills in real life as well, not just vocationally specific, but what the students will do every day, such as setting alarms to get up, like working out how long it takes them to get to college or school, calculating bus fares and budgeting, all of those things that they probably do in terms of maths that maybe they don't really think of as maths. And therefore also try to promote a growth mindset. So I have put a link there to a growth mindset website, which got some really nice ideas and thoughts around improving students' attitudes towards maths. And avoid treating maths as something that's hard. It's a really common concept that only clever people are good at maths, and often that can be reinforced by parents or teachers saying, yes, I always struggled with it at school. So try to take that away a little bit and allow students to feel safe and make mistakes, and not be frightened to make mistakes. And then I've added this in here, learn to love your calculator. So students can have calculators in their T-level exams, so it's worth spending a little bit of time teaching students how to use a calculator. It's easy in lessons to say, just use your phone. We don't have calculators, just use your phone as a calculator. But obviously they can't do that in the exams. So it is worthwhile practicing using a calculator across the year. So because there are a lot of functions on calculators that are really, really useful. And some of your students might be pretty adept with a calculator and be able to help each other and show them some really useful stuff, like how to convert between fractions, decimals and percentages, using the fraction function, interpreting the display correctly as well, like understanding what it is the calculator's telling them. And there's a link there to the Maths Genie website, which does have a little video around how to use a scientific calculator that you might find useful as well. In terms of useful resources, the website is full of maths activities and resources. I have put together a Padlet there. You can see the screenshot and the web addresses at the top. And I've linked quite a few useful websites that I've used myself in the past here already. There's some teaching resources. There's some links to like quiz and game type websites. There's useful videos, quite short videos that students might find useful if they're stuck on one particular aspect of maths. And there's also some CPD and research suggestions for yourself as a teacher. Feel free to add more to that. It's a sharing platform, so it'd be great if people, keep it going and add more resources over time. I've also would suggest that on the NCFE website, the Certificate in Essential Maths in Everyday Life qualification actually has some maths workbooks. I've put the link there to the level 2 one. There's also level 1. And these workbooks are actually really useful, not only for your students to practice their maths, but for yourself as well, if you feel there's any areas you need to upskill a little bit. So the link's there to use those as well. So in terms of feedback, this was the link for the live event, but if you're listening to this as the recorded version, I would still really appreciate understanding what type of future math support would be most beneficial. So for example, it might be that you would like CPD sessions on subject-specific maths applications. It might be that you would like some ideas for teaching resources tailored to T-levels. You might want guidance on how to embed maths into your T-level content. Or you might want some ideas around assessment and how to assess your students' math skills and help them to progress. So I've put my email address on there. So if you do have any ideas of something you would like in the future around embedding and promoting maths in T-levels, please let me know. It would be great. Thank you. And finally, thank you so much for watching this video today. I hope you found it useful.